Okay. Hello, BC students. This is like my third time recording this, but so I'm going through the week 2 homework packet. I'm gonna try to remember to switch values as we go through each problem, just so I can show you how the problem's done. But I'm gonna switch the values so you actually are gonna have to solve the problem yourself. One other thing is I would like for everyone to really try to attempt the problem themselves before they just look at how I do it. I will say, especially for the related rates problems here. I'll say this because for these problems, right, where we're just differentiating, like implicit differentiation, I feel like it's kind of like you either know how to do it or you don't. So you can either do it yourself or like you don't know how to do it, so you just watch me do it. The related rates problems, I think everyone has the skills, the toolbox, I guess, to solve these problems. The thing is with the related rates problems, they're not as concrete. They're not like, oh, you just do steps A, B, and C and you get the answer. There's elements of that for sure. Like related rates problems are extremely similar, but also some of it is like you kind of pick and choose pieces like as you go. You'll like solve for like, oh, dA over dt, right? You find the area, but then you're like, oh wait, like I realize I need to solve for the radius here, and then I can figure out the problem. Like there's just different elements, and I will show you as I go through the related rates problems, like what I mean by that. Like they're more like free form. As long as you have the skill set and like you understand how different variables work together, then you can solve the problem. But yeah, it's not as concrete as just like this, where it's just like differentiate with respect to t, which is the first problem, which is differentiate each of the equations with respect to t. First thing I notice is that there's no t in the equation. It's x and y. So both of these variables are going to undergo implicit differentiation. So I'm going to rewrite this as e to the x plus 12 equals 2y, for example, just even though it's extremely similar. So d over dt of e to the x plus 12 is equal to d over dt of 2y. Okay, cool. D over dt of e to the x. So we're differentiating the derivative of e to the x, we all know is e to the x, right? Cool, but we're not done. Remember, we're differentiating with respect to t. So it's a separate variable, a different variable than x. So we have to multiply by dx over dt, right? Now we're adding derivative of 12 is just 0, right? So anything we multiply by 0, we can multiply that by d over dt. It's still going to be 0. So basically, we're done. On the left side, we're done, right? So we're done on the left side. Now, d over dt of 2y. Okay, so what's a derivative of like 2x or like 2 whatever? It's just going to be 2. So it's going to be 2, but we're differentiating y with respect to t now. Okay, so we can't forget, we still have to do implicit differentiation. So it's 2, and then you just multiply by dy over dt. Remember implicit differentiation? You always just multiply it by the d whatever you're taking with respect to the variable you're differentiating. So just always just multiply it. So that's actually our answer. Right? Yeah, so it asks us to differentiate each of the equations with respect to t, but it doesn't say to solve for like a specific rate. So it doesn't ask us to solve for dx over dt. So like we can just leave it like this. So that is our answer. We're done. Now this problem, volume of a cylinder. I'm going to change this, although honestly this barely changes anything, but I'm going to change this to volume of a cone is equal to v is equal to pi over 3 r squared h. It's extremely similar, but whatever, I changed it. So let's, with respect to t, differentiate with respect to t, d over dt of v is equal to d over dt of pi over 3 r squared h. Cool, so let's start from the left. D over dt of v, well, that's just going to be d over dt of any variable, right? That's just going to be 1. But we're differentiating with respect to t, so it's going to be multiplying by dv over dt. So really, it's just going to be dv over dt is equal to, the thing is with this part, the right of the equation, right? There's a pi over 3. So I'm going to apply what I know about derivatives and like constants and stuff, and I'm just going to factor out the pi over 3. So I'm going to do that over here, actually. So I'm going to say pi over 3 of d over dt of r squared h, because I know constants don't impact derivatives. They just stay the same, right? So I can factor constants out. That way, this is easier for me to look at. It's just two variables. And the reason I do that, right, is because I look at these two variables and I understand I'm going to have to do product rule. And if I have a pi over 3, I don't know, that just makes it more confusing for me. Like for here, for this example, right, 2y, I don't really have to take the 2 out, although I effectively did this, like it comes out to the same answer. I could take the 2 out. But this isn't as confusing because I'm not doing product rule. But here I'm doing product rule. So let's find let's do everything. So u is equal to r squared, right? Here, let's do pi over 3, right? So pi over 3, I'm going to multiply now by d over dt of r squared h. So let's find d over dt of r squared h. Okay, let's do product rule because it's r squared times h. So u is equal to r squared, v is equal to h, u prime is equal to 2r. Okay, 2r, cool, but we have to differentiate with respect to t. So 2r multiplied by 2r over dr over dt. V prime is equal to h. Well, I'm sorry, v is equal to h. So v prime is equal to like just 1, right? Because the derivative of like a single variable is 1. But we have to multiply again by dh over dt. I keep on emphasizing this for implicit differentiation, but just always just multiply it. So it's just dh over dt. Cool. So now we have uv prime plus vu prime. This is product rule, right? So let's multiply pi over 3 by this, by uv prime plus vu prime. Well, what is uv prime? uv prime is r squared times dh over dt. So it's going to be r squared times dh over dt plus vu prime. Well, v is h, u prime is 2r dr over dt. So it's going to be, let's say 2rh dr over dt. Now this is effectively our answer again, because I mean, we can distribute the pi over 3 if you want. If you want to multiply out pi over 3 to this and this, then go for it. But we can leave it like this because we differentiated, we're done. And it doesn't ask us to solve for anything. So cool. Now this problem. I was working my way through this problem earlier when I realized I didn't change any of the values and I didn't want to just give everyone the answers. So that's why I restarted filming this. But this is a related rates problem. I would say this problem is extremely valuable, really good practice for related rates. So if you want to practice related rates, practice this problem because it takes one, I'll show. So just try each problem first, but it's because this problem will use all different equations. So it's like almost 3 related rates problems contained into one, which isn't as bad as you might think, in my opinion. But so let's start off with, okay, so I'm going to change this to not a 13-foot ladder, a 5-foot ladder, okay? So 5-foot ladder is leaning against a wall when its base starts to slide away from the wall. By the time its base is, let's say, 4 feet, the base is moving at a rate of, let's say, 2 feet per second. Okay, so for me, I'm going to draw out what this means. So a 5-foot ladder is leaning against a wall. Okay, that's pretty obvious what that means. This ladder right here is 5 feet. When its base starts to slide away from the wall, so this is going away from the wall, right? The base is starting to slide away. By the time its base is 4 feet from the wall, okay, so by the time the base is 4 feet from the wall, so that means by the time this is 4 feet, right? So x is 4 feet. So I'm going to write that down, actually. I'm going to label this as r too. Okay, so the hypotenuse here, the length of the ladder is r. So I know r is equal to 5, right? X is equal to 4. The base is, and then we're told that the base is moving at a rate of 2 feet per second. Oh, okay, so when x is equal to 4, I know that the base is sliding at 2 feet per second. Okay, so that means when x is equal to 4, one thing to keep in mind, when, like, let's say when x is equal to 3, we don't know what, if it's sliding away at 2 feet per second. All we know is that at this exact moment, when the base is like, when it hits 4 feet, we know that the ladder is sliding away at 2 feet per second. So that's important to keep in mind. What we actually know is just what the ladder is doing at this exact moment in time. So 2 feet per second. Well, what does that really mean? What is that? That's the change in x, right? So the change in x over change in time. So that's dx over dt. We're told that dx, I'll write the rates over here. So we're told that dx over dt is equal to 2. Cool. That's all we know right now, right? That's all we know. That's the values that we're given. So let's just try to solve the problem. Let's try to solve part A. So I'm rewriting this. Okay, so A, how fast is the top of the ladder sliding down the wall? So if we want to find how fast the top of the ladder is sliding down the wall, that means how fast this is happening, right? Okay, cool. So what would that rate be? If we know if this is dx over dt, then how fast y is changing, right? How fast y is changing? That's dy over dt. Okay, so we want to find dy over dt. That's our big question mark. That's what we want to find. Okay, so how do we do that? Well, we want to find dy over dt. So how do we find that? Well, what equation should we use? That's our next step, right? We found all of like what we know, but what equation should we use now? Well, what relates x, y, and r, right? Because that's essentially what they're asking us to do. We have x, y, we have x and r, and we know like dx over dt. What relates x, y, and r? It's a right triangle, Pythagorean theorem. We've done this before in class. So we're told that, we know that Pythagorean theorem is x squared plus y squared is equal to r squared in our case, right? Because r is the hypotenuse in this case. So x squared plus y squared equals r squared. Well, let's differentiate with respect to t, all right? Because that's what we do in related rates problems. X squared plus y squared is equal to d over dt of r squared. Okay, so what is that going to be? D over dt of x squared. Okay, so the derivative of x squared is going to be 2x according to power rule, but we're differentiating with respect to t again. Remember, always that. So we're multiplying by dx over dt. Now differentiating y squared. Okay, so it's going to be 2y, right? But we're differentiating with respect to t again, so dy over dt, multiplied by dy over dt is equal to, this is going to be the same pattern, 2r, now to dr over dt. Okay, so here's, I think, like where related rates problems are like, you just kind of have to like, just start the problem and then you'll figure it out as you go along. So let's say I'm going to substitute everything that I know into this equation so we can find dy over dt, right? Because that's our ultimate goal. That's what we want to find. So 2x, well, what is 2x? X is, what did I say x is? X is 4. So 2 times 4 times dx over dt, which we've said is 2, right? Dx over dt is 2. So 2 times 4 times 2. Awesome. We have everything here. Plus 2 times y. Oh no, wait. Look over here. I don't have a y. Okay, so what do we do for y? Oh, wait a second. You see, this is where like I'm like, you kind of just do the problem, and once you go, you can you figure out how what you need to do. So we have x, r. We don't have y, but it's a right triangle. So wait, why don't we just apply Pythagorean theorem? X squared plus y squared is equal to r squared. So let's just quickly solve for y. It's easy to solve for y. We have two sides of right triangle. We use Pythagorean theorem to solve for the third side. So x squared is equal to, if you're familiar with this pattern already, you already know that y is equal to, we'll see. Anyway, so x squared is 4 plus y squared is equal to r squared is 5 squared, right? So it's going to be 16 plus y squared is equal to 25. So y squared is going to be equal to 9, right? 25 minus 16 is 9. So y is equal to 3. Oh, cool. So we just literally solve for y. When x is equal to 4, y is equal to 3. We solve for y. That's great. So now we have this answer. So I mean, we have this 2 times 3 times dy over dt. This is fine that we don't know that because that's what we're really calculating for. It's equal to 2r. Okay, so r is 5 times dr over dt. Oh no, it looks like we don't know dr over dt either. Okay, well, again, this is where it comes into play, like related rates problems. You just got to kind of just do it and try to think. So what is dr over dt? What does that really mean? So dx over dt, let's look at dx over dt means how x is changing over time, right? So x is, if you imagine a ladder, like x is the distance between the base of the ladder and the building. X is changing at 2 feet per second, we're told that. Y, dy over dt we're solving for. Well, what is dr over dt? How does r change over time? Well, R is a fixed ladder. We talked about this before, right? It's a fixed metal ladder. It's not going to change over time. Y and X are the things that are changing. R is going to be the same. So dr over dt, it's not changing. It's going to be 0. So we're multiplying this whole thing by 0. So that means this is just 0. Okay, well, this is pretty nice. Now we only have one unknown. We only have dy over dt. Now we can actually solve for it. So it's going to be 16, right? 2 times 4 times 2 is equal to 16, plus 6 dy over dt. So that's going to be, is equal to 0. So 6 dy over dt. Now, one thing we should notice, right? We should be getting, y is falling down, right? So we should be getting a negative number, right? X is going in the positive direction, so that's positive. It's 2, right? If the ladder was going inwards for some reason, it'd be negative 2. So that's one thing to notice. So y should be negative. So let's see if we get that. 6 dy over dt is equal to negative 16, right? Because we're moving the 16 to the other side. So dy over dt is equal to negative 16 over 6. Awesome. So that's feet per second. We solved the problem. So we know now that the ladder is going down at negative 16 over 6 feet per second. So that's like just under negative, it's just under 3 feet per second. It's going down. So negative 16 over 6 feet per second. So I'm gonna actually just write that dy over dt is equal to negative 16 over 6. Cool, we have like everything figured out now. We have we have x, y, and r, and dx over dt, dy over dt, and dr over dt. That's like, I don't even know what else we need. But let's see part B. So part B is saying, at what rate is the area of the triangle formed by the wall, ladder, and the ground changing at the same time? Okay, so our first step again is to figure out what do we know? Well, I feel very confident because from our first problem, we kind of already know everything, it seems like, in my opinion at least. So let's try to just solve for it. So at what rate is the area of the triangle? Okay, area of the triangle. I feel like that makes it pretty obvious what equation we should use, and that is area is equal to 1/2 base times height, right? That's the area of a triangle. That's the equation. Cool. But whoa, we have a base and height, b and h. What is that? Okay, well, we're really just using different variables. Like b is x, right? So that's the base of the triangle. Height is y, right? So it's going to be really is equal to 1/2 xy, right? So let's do d over dt of a, right? We're trying to find the change in area. So actually, I could write this down. We're trying to find dA over dt, right? The change in area over the change in time. That's our big question mark for this one. So d over dt is equal to d over dt of 1/2 xy. So I'm going to solve for this. So d over dt of a. So remember the same process, that's going to end up as dA over dt is equal to d over dt of 1/2 xy. I'm going to take out the 1/2 first. 1/2, right? I talked about that earlier. You can kind of just factor out constants. So d over dt of xy. Okay, so now this is a clear product rule situation because we have two variables. So u is equal to x, let's say, v is equal to y. What is u prime? U prime is just going to be equal to 1, right? Because the derivative of x is 1. correct, but remember it's implicit differentiation. We're differentiating with respect to t, so always multiply 1 by dx over dt. So again, it's just going to be dx over dt. Now v prime is equal, it's going to be dy over dt then, right? Now uv prime plus vu prime. So really we're going to get dA over dt is equal to 1/2 multiplied by our whole product rule thing, which is going to be what? uv prime is going to be equal to x dy over dt, right? Because that's u and v prime. Plus vu prime, so that's going to be y dx dt. Kind of confusing. It's like they're mixing it up, x dy over dt plus y dx over dt. But cool. Let's see if we can substitute in stuff now. So dA over dt, which is what we're solving for, is equal to 1/2. And x, we already know, is 4 times dy over dt. dy over dt is negative 16 over 6. Cool. Plus y. Y is 3. We solved for that already. Times dx over dt, which is 2. Cool. This is just a thing where we got to solve it because we got all the answers, like we filled in all of the values because we already did a bunch of work in the first problem where we got all the values. Okay, so I'm not going to solve for this just because I am lazy and I don't know what that is equal to, but when you do the problem, I'm sure you can solve for it. Remember, I have the values changed, so do not just copy exactly what I do. Okay, so at what part C, at what rate is the angle theta between the ladder and the ground changing then? Okay, so I really like this problem because, okay, so if you haven't done it yet, I would recommend you just think about part C because you'll be like, wow, I didn't even know you could apply related rates to this type of stuff. But just think about it. So at what rate is the angle theta between the ladder and the ground changing then? So just pause now if you haven't tried it yet, but try this problem. So the angle, so unpause, the angle theta between the ladder and the ground. So this is the angle theta, right? Because that's between the ladder and the ground, right? So cool. How do I find the rate for the angle? So wouldn't the rate for the angle then be, if I think about it, the rate for the angle, that's d theta over dt, right? That's what I'm looking for. That's our question mark, right? That's the rate of change of the angle over time. So how can I relate theta to the ladder and the ground to like x, y, and r? Well, if you think about it, you can actually apply, I think, any trigonometric identity. We know that, for example, the equation is tangent of theta is equal to opposite, right, SOHCAHTOA. So it's going to be the opposite over the adjacent. So it's going to be y over x, right? The opposite of this theta is y, the adjacent is x, right? So hopefully you guys remember that. That's kind of some trig stuff you need to remember, right? So I'll just clarify. So this is our angle theta, right? The opposite to this angle would be the opposite. O is going to be y, right? Because it's like opposite. The adjacent one is going to be the one that's next to the angle. That's not the hypotenuse, because the hypotenuse is always this, the long side, right? So this is adjacent, and then h is the hypotenuse. So anyway, so opposite over adjacent is going to be y over x. Let's see, sine of theta. Sine is opposite over hypotenuse, right? SOHCAHTOA, S-O-H. So opposite over hypotenuse, which would be y over r. Cosine of theta is equal to, so adjacent over hypotenuse. So it's going to be x over r. And we we already know all these values. We can literally use any of them. So I'm going to use tangent of theta just because. So tangent of theta, that's going to be the equation that we use. Tangent of theta is equal to, what is it? Yeah, y over x, right? Sorry, one sec. It's going to be equal to y over x. So let's differentiate this with respect to t. This will be interesting. D over dt of tangent theta is equal to d over dt of y over x. Okay, well, what's d over dt of tangent theta? So what's first? What's the derivative of tangent? Is going to be secant squared, right? So it's going to be secant squared of theta. Cool. But now we have to remember we're differentiating with respect to theta, with respect to t, and we're using theta, which is a different variable, so we need to multiply by d theta over dt. Now, it's going to be equal to d over dt of y over x. Well, okay, so we got y over x. So what are we really going to need to do? We're going to need to do a quotient rule. So I'm going to erase all this just because I'm kind of running out of space. Yeah, I'm going to erase some of this too, just so it's not as cluttered. Okay, so u is equal to y in this case. V is equal to x. We'll go through this. U prime is equal to dy over dt. Remember, it's not just one. V prime is equal to dx over dt. And then quotient rule is vu prime minus uv prime all over v squared. So this is going to be equal to, what is vu prime? Vu prime is x dy over dt minus uv prime, which is y dx over dt, all over v squared, so all over x squared. Okay, so let us solve for everything. Secant squared theta d theta over dt is equal to x times dy over dt, x times dy over dt. Okay, so we know all the values for this. I'm not going to solve for this, but so let's just say this is some arbitrary value. So that's this side of the equation right here. Cool, so I solve for that. Let's say I get a number and it's like whatever. Let's say the number is just 10. Okay, so d theta over dt is equal to 10 over secant squared theta. Oh, cool. Wait a second. I still don't have an answer, right? Because I still have the secant squared of theta. What do I need to solve this? I need to find what theta is equal to. So I need to find this angle. Remember, this is where this is why related rates problems, you can't always predict everything. Like, it turns out we still have to solve for something. So we need to find what theta is equal to. How do we do this? Well, we know we should be able to do this, right? Because we have literally theta. We have literally a right triangle where all three sides are defined. So like, we can solve for this. We can solve for theta. You need to remember how to do it now. So you're probably going to need to get your calculator out because we're going to need to use inverse trig functions. So honestly, I haven't even done this in a long time, but I know that tangent, this is how it works. So tangent of theta is equal to y over x, right? So it's going to be 3 over 4. I know that's what tangent of theta is equal to, right? It's going to be y over x is equal to 3 over 4. Okay, so basically I'm going to use tangent inverse of 3 over 4, and that should give us theta. So kind of you got to pull up your trig memory stuff here, but it's going to give us theta. So once you find theta, we can now input theta into here, right? So now we have d theta over dt is equal to something we actually can solve for. So, okay, this last problem is kind of hard, I'm not gonna lie. So if you were able to solve this without any help, that is good job, good job. But yeah. Yeah, yep. So again, for these inverse trig functions, it's literally like you put what the answer was for, like, so tangent of theta is 3/4. So if you want to find theta, then you put the 3/4 into the inverse trig function. So like switches them around basically. So then you can find theta. Anyway. But that's like, I really like these related rates problems because it's like you can find out so many. You can find how the angle changes over time, which I find like so interesting. How theta changes over time. And I like how it's like, it's kind of like a free for all problem. Like, you know what you have to do kind of, but as you go along, there's always different obstacles, but like you can use your tools, you can use what you know to solve for the obstacles. Okay, let's see this problem. Okay, let's do this problem. Okay, so this is an actual problem from the 2019 BC exam. Part C, you don't know how to do yet because that involves integration. So if you downloaded a copy of the PDF earlier, you might have had part C still like on the PDF. Don't do part C if that happened to you. Okay, but let's read this. So a cylindrical barrel with a diameter of 2 feet. Okay, so the diameter is 2 feet. Cool. This here, diameter is 2 feet. Contains collected rainwater as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel. Okay, so it drains out through a valve. So I'm guessing this thing is decreasing, right? So the height is decreasing. So the rate of the change of height of the water of the barrel with respect to time is, okay, yeah, it's decreasing at a rate of that. So dH over dt, we're told dH over dt with respect to, so it changes, it's a variable, it changes with respect to the height. So it's not like a fixed number, right? It's not just like 2. It changes with respect to height. Where h is measured in feet and t is measured in seconds. Find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Okay, so when the height of the water is 4 feet, well, now we kind of know what dH over dt is, right? So let's see. I haven't actually done this problem, so I'm going to this is me winging it almost. dH over dt is equal to -1/10 square root of h. Well, I know h is 4. Let's see what else I know. So find the rate of change of the volume of water in the barrel. So I want to find dV over dt. That's our big question mark, right? I have dH over dt. And I also have the volume of a cylinder. Okay, that's very useful. So dH over dt is going to be equal to, right, at h equal to 4, so -1 over 10 root 4 is equal to -2 over 10 is equal to -1/5. Right, so I kind of actually do know what dH over dt is equal to. It's equal to -1/5 at this specific height. If it's a different height, then it will be a different. Oh shoot, I need to change these values. Okay, I'm gonna change these values really quick. So I'm gonna change this diameter to 4 feet, and I'm gonna change this height to I'm going to change the height to, okay, say 8 feet. No, let's say 6 feet. Okay, I'm going to change this to, no, actually, no. 4, 2, let's change it to 16 feet. Okay, 16 feet. And instead of -1/10, it's going to be -1/8 root h. Okay, so all these values are changed. Okay, so it's equal to -1/8 root h. Okay, so same deal, -1/8 root the height. Wait, did I change the height? Oh yeah, the height is 16 now. So, okay, so let's restart this problem. -1/8 root 16 is equal to -1/8 times 4 is equal to -1/2. Okay, so I have dh over dt is equal to -1/2. Okay, sorry, my internet disconnected for whatever reason. So going back, I have that the height is equal to -1/2, right? Because I just solved for that. So I have dh over dt. What am I even solving for again? I forget. So dv over dt. I have dh over dt. And the volume, I have my equation. So v is equal to pi r squared h. Cool. So my first instinct would be to differentiate it, right? Now, you could do all that. You could, but if you think ahead, there's actually a more effective way to do this. So if you don't want to differentiate this whole thing, like, okay, why this is kind of annoying is, let's say we differentiate this whole thing, right, with respect to d over dt, like the whole thing. We know we're going to have to do a product rule, right? Because we have r squared h. And that's going to be a little bit messy, right? But if we can do all that actually. But if you don't want to do that, think about what r actually is. Is r really a variable? Like, we're told what r is. Oh, I should have written that down. Oh my God. Okay, so d is equal to 4, right? So r is equal to 2. We're told what r is, right? So d, the diameter is equal to 4. So r is equal to 2. So let's just, and r does not change. It's not like h. H is changing. R doesn't change. So r is always going to be 2. So let's just plug that in. So it's going to be v is equal to 4 pi h, right? Because r is 2, so 2 squared. So it's going to be 4 pi h. So now this is much more pleasant to okay. Sorry about that. So this is much easier to differentiate with respect to time, right? Like it's literally so easy. So d over dt of v is equal to d over dt of 4 pi h. So that's going to be equal to, sorry, the v over dt, right, is equal to 4 pi dh over dt. Cool. And then we're told what dh over dt is at 16 feet. We already calculated at 16 feet. We already calculated for that. So dv over dt is equal to 4 pi dh over dt. Notice that like we have an equation for dh over dt. So it's like, oh, like maybe we don't actually know it yet, but we do know dh over dt because we know h. So we can just plug h in and we got negative 1/2. So 4 pi times negative 1/2 is equal to negative 2 pi. And then the units are, what is it, feet per second. So in my example, this is decreasing at 2 pi feet per second. Cool. How pleasant. I enjoy solving, getting the nice answer. Okay, so we have dh over dt. Actually, let's just, or wait. Oh, sorry. That's the area is changing at 2 pi per second. So it's okay. The volume, sorry. So it's 2 feet. Oh, I'm dumb. Sorry, 2 feet cubed per second. So the whole volume is changing at 2. So this whole thing is like shrinking. It's leaking out at 2 feet per second. 2 pi feet cubed per second. Sorry about that. So 2 pi feet cubed per second. So I don't remember what we're actually solving for. Okay, so now part B is when the height of the water is 3 feet, so when h is 3, is the rate of change of the height of the water with respect to time increasing or decreasing? Okay, so you can try to solve for this again, but this is a hard problem. So think about what this means. Is the rate of change of the height of water with respect to time increasing or decreasing? So is the rate of change of the height of water? Well, we already know the rate of change of the height of water, right? It's this equation, right? And then they're asking us for a different height this time, right? When the height of water, okay, I'm gonna change this to when the height of water is 4 feet. When it's 4 feet. When the height of water is 4 feet, is the rate of change of the height of water with respect to time increasing or decreasing? Well, we can already figure out what the height of water is. So I'm trying to get you to think about this. So the height of water at 4 feet is going to be, or the rate of change of the height of water at 4 feet is going to be square root of 4 is equal to negative 2 over 8 is equal to negative 1/4, right? So in this case, dh over dt is equal to negative 1/4. But this is asking us, is this rate of change increasing or decreasing? So is negative 1/4 increasing or decreasing? Okay, so it's not even, we already know the rate. Now we're asking if the rate is increasing or decreasing. Does that make sense? So think about what that means. We know a rate, and now we're asked if that is increasing or decreasing. That kind of sounds like we have to take the derivative again, so we can figure out if the derivative of the rate, right? The rate is already a derivative, but is the rate, is that rate increasing or decreasing? So what is the rate of that rate, kind of? So it's a second derivative. So let's find out. Let us find out. We know that the rate for the height, the rate for the height dh over dt is negative 1/8 root h. So let's find the second derivative of that to find, is the rate of the height, is this increasing or decreasing? So that's, the notation would be, I don't think you have to show it like this. You can like just say like h double prime of t, right? That's the height double prime. So h of t, right, is already, we're already told this is equal to negative 1/8 root h. But we want to know if this is at 4 feet, if that's increasing or decreasing. So we need to find h double prime of t is equal to, what is that? So that's, so I remember negative 1/8 h to the 1/2, right? So power rule, so multiply by 1/2. No, that's just kind of ugly. Negative 1/16 h to the negative 1/2, right? Because I subtract 1 from the exponent, so that's negative 1 over 16. 16 square root of h. Okay, cool. So now I have our equation. Now I know whether the height, the change in height, whether that's changing or not. So it's almost like, okay, actually, this is a good way to think about it in case this part is confusing you. It's like when we learned about position, speed, and acceleration. So position, we're told the position is equal to, we already know what the position is, right, of the height. Now speed, that's dh over dt. So that's how fast is this water, like is the water leaking out? How fast is the level of the water? It's like going down in the cylinder, right? That's speed. Now the second derivative, that's asking us, is this speed changing? So the speed, let's say it's going down, well, we already saw for like the speed was going down at like whatever, negative 2 feet per second, let's say. Now, what if it's that speed is changing? What if it's like accelerating? What if it's going from -2 and then the next second is going to be going at -3? So that it's like accelerating. It's not just consistently going at -2. It's like the speed is also changing. So that's also kind of acceleration. That's speed is change in position over change in time, right? Acceleration is change in speed over change in time. So how is the speed also changing? It's like when you're driving, I can be driving at 40 miles an hour. That's my rate, right? But what if that rate is changing? What if I'm going from 40 to 50? You know what I mean? So I can actually calculate the rate of this change in speed too. I hope I'm not pushing this too much, but hopefully it makes sense. So that's what this is calculating. It's like how much is this water accelerating almost? How much is it accelerating? So at h equals 4, it's going to be equal to negative 1 over 16. Root 4 is equal to negative 1 over 16 times 2 is equal to negative 1 over 32. So in this case, it is decreasing because it's negative. That's all we need to know. Negative, so decreasing. Cool, we are done. We don't care about the exact rate, although we solve for it. All we need to know is that it's decreasing. Okay, so that's a lot, but okay, so let's move on to the next problem. So simply write L'Hopital's rule in the space below. So L'Hopital's rule is that the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. I actually forget exactly what the notation is here, but it's something like that. But this only applies when we have one of these indeterminate forms. And remember, I gave you that list of indeterminate forms, but indeterminate forms are like 0 over 0 or infinity over infinity. So when you solve for a limit and you just like plug it in and you get one of these, then we know we can apply L'Hopital's. And L'Hopital's is literally, look, f to f prime. So you just find the derivative of the numerator and then the derivative of the denominator. So let's see problem number 2. So, okay, let's just confirm we can use L'Hopital's because this section, I'm assuming it's suggesting we should use L'Hopital's, but here, okay, I'm not going to switch these values because, yeah. So if I plug in -3 in the numerator, so -3 squared plus 11 times -3 plus 24, that's going to be equal to +9 minus 33 plus 24, which is equal to 0. The bottom, -3, this is the denominator, -3 squared minus 2 times -3 minus 15 is going to be equal to 9 plus 6, right? -2 times -3 is +6 minus 15 is equal to 0. So I'm getting a determinate form, an indeterminate form, 0 over 0. Cool, now I know I can apply L'Hopital's rule. So L'Hopital's rule means I just factor. So I'm going to make this very explicit. So the limit as x approaches -3 of, I'm rewriting the problem, of 11x plus 24 over x squared minus 2x minus 15 is equal to the limit as x approaches -3 of the derivative of this top part over the derivative of that part. So it's like a very, oh my God, okay, it's a very pleasant and intuitive rule, I feel like. So what's the derivative of x squared plus 11x plus 24? So it's going to be like 2x plus 11. The denominator is going to be 2x minus 2. So these are equivalent. They are identical. And that's what L'Hopital's rule tells us. It is exactly identical. And then you can solve for it from here. Because now, when we plug in -3, we get an actual answer. We don't get an indeterminate form. There are actually questions where sometimes you plug it in the second time again, you plug it in, you get another indeterminate form. And then you can do L'Hopital's rule a second time, actually. So yeah. This problem was on your quiz. And I'm actually just not going to show you guys how to do this problem. The only thing, because like it's the same exact concept. Take the derivative of this side, derivative over the derivative of the numerator, and then just solve for it. I will say though, you will have to know like square root of x turns into x to the 1/2, right? And then you can do power rule for that. So what's the power rule of that is 1/2 x to the -1/2. You can bring that to the bottom, so it's 2 to the 1/2. So it's like that's what it'd be equal to, 1/2 root x. But you have to know how to do your algebra. So that's one thing I'd help you with. But that is it for this packet. I will say I think the related rates problems are actually kind of tedious, but besides that, it should be pretty quick. So good luck, and if you have any questions, please just ask me.